Hello. Hello. Let's look at more examples on integrations involving trigonometry substitution. Okay. Now, looking at this integration, we asked to integrate this, and it is of trigonometry substitution. What kind of substitution I'm going to use here? From the look of the question, I'm having at the denominator part, I'm having my constant here to be what? 4. And this is ordinary x. What trig substitution can I apply that will, one way or the other, at the end of everything, this square root will eliminate? If I use 2 sine theta, if I put 2 sine theta here, is it going to help me eliminate the square root? No, because 2 sine theta, there's no way, because there's no square on the x. So 2 sine theta cannot work. But better still, I can say let x be 4 sine square theta. So if x is 4 sine square theta, then it means at the denominator I'll end up having something like 4 minus 4 sine square theta, which if you factorize, that will be giving us 4 into bracket 1 minus sine square theta, which is the same thing as 4 cos square theta. So at this point, I can square root this. If I take the square root of this, it will give us 2 cos theta, okay? So that will be the substitution I'll be making use for this particular question. So let's solve that together, okay? So I can say solution. Let x equals 4 sine square theta, okay? So if this is x, I'll have to differentiate it. Then I can say that dx, while differentiating, dx will give us 8 sine theta cos theta d theta, okay? D theta. So that's the derivative. So since I'm trying to use trig substitution, then it means the boundary is changing from with respect to x to with respect to what? To with respect to theta. Then I have to look for my my limits. I have to change it from with respect to x to what? To with respect to theta. So I can say that change of limit. Change of limit, okay? For the upper boundary, when x, for the upper boundary it is 2 here, then that will be 2 is equal to 4 sine square theta. When I break it down, I have it to be 1 over 2 is equal to sine square theta. Therefore, theta will be what? If I make theta the subject of the formula, theta will be pi over 4. Pi over 4. That's for the upper boundary. And then for the lower boundary, when x is equal to 0, when x is equal to 0, okay, then that will be 0 is equal to 4 sine square theta. If I make theta the subject of the formula, then it means theta is equal to 0, okay? Now I'm trying to change the question. The question is in form of what? With respect to x. I'm trying to move it to with respect to theta. Therefore, I can say that the initial question I'm given to solve is the same thing as this initial question is the same thing as the integral, the boundary, lower boundary is 0. Now, if the lower boundary of x is 0, with respect to theta is also 0, that's 0. The upper boundary is 2 here, with respect to theta, that's pi over 4. Then that's pi over 4, okay? The square root of x. What is x? X is 4 sine square theta. That's 4 sine square theta divided by 4 minus, what is x? 4 sine square theta times dx. But what is dx? Dx is the same thing as 8 sine theta cos theta. That's times 8 sine theta cos theta d theta. Okay, so this is what we'll be simplifying now. So let's try to break this down. Now, looking at this denominator is the same thing as 4 into bracket 1 minus sine square theta, right? If I factorize, and you all know that from basic identity 1 minus sine square theta is cos square theta, so I can say it's the same thing as 4 cos square theta. So that's for this denominator. So we have the integral from 0 to pi over 4, the square root of 4 sine square theta over 4 cos square theta times 8 sine theta cos theta d theta. Okay, now this 4 eliminate this 4, the square root. Now if I'm to remove the square root of sine square theta is what? Sine theta. The square root of cos square theta is what? Cos theta. So I'll be having it to be the integral from 0 to pi over 4 sine theta over cos theta times 8 sine theta cos theta d theta. Okay, now this eliminates this. If I multiply that together, we have it to be 8 is a constant, integral 0 to pi over 4 sine multiply sine, it gives us sine square theta d theta. Okay, and from our standard techniques, when you integrate sine square theta, if you integrate sine, the integral of sine square theta is the same thing as theta over 2 minus sine 2 theta over 4. So I can say that here we have our answer to be 8 into bracket. The integral of sine square theta is theta over 2 minus sine 2 theta over 4. Close the bracket. Boundary is 0 to pi over 4. Okay, now let's apply our boundary first. Apply my boundary, I have it to be it's before applying my boundary, let me try to open the bracket. If I open the bracket, I have it to be 4 into bracket. Okay, yeah, 4 into bracket theta minus sine 2 theta over 2. Yeah, that's correct. Then I have from 0 to pi over 4. Okay, now let's try to what? Let's substitute. When I substitute my boundary, upper boundary, let me use my red pen. So upper boundary is going in. That will give us 4 into bracket. The upper boundary, that's pi over 4. Okay, minus if I substitute my upper boundary here, if I put pi over 4 here, that will give us sine. If I put pi over 4 here, that will give us 2 pi over 4. And 2 pi over 4 is the same thing as 180, right? Yeah, it's the same thing as 90, sorry. 2 pi over 4, look at it. 2 pi over 4. 2 here 1, 2 here 2. Pi is 180. 180 divided by 2 is what? 90. So that's the same thing as sine 90. And sine 90 is the same thing as what? 1. Sine 90 is the same thing as 1. And sine 0 is 0. So if sine 90 is 1, here we have it to be what? Minus 1 over 2. That's for upper boundary. Minus lower boundary. When you substitute 0 here, you have 0. Minus when you substitute 0 here, you have 0. Sure you get. So this is our what? Our final answer. So if I open this bracket, I end up having 4 minus if I open the bracket, I end up having 4 times this. To open that bracket, we're having 4 is equal to this. 4 is multiplying everything here. So 4 times this will give us pi. Minus 4 times 1 over 2 will give us 2. Therefore, the final answer is pi over 2. Okay, so that's what we call integration by trigonometry substitution. So the techniques behind it is just for you to be able to identify the right substitution for that particular question. And if it is a definite integral, you should apply change of limit to change the base to what? To change the boundary from with respect to x to with respect to what? With respect to theta. So that's what we call change of integration by trigonometry substitution. Thank you.